Here's a question I have for all of you. What was the largest cause of cancer death in the United States in women in 1952? Number one. Everyone had a mother, a sister, a daughter, a grandmother, a niece who died of this cancer. 1952. Jeopardy here. What's the number one cause of cancer death in 1952 in American women? Who wants to venture a guess? Uterine? No. It's close.
Cervical.
Cervical, right. A lot of, you'd be amazed how many people say lung, breast. No. Cervical cancer. It's tiny little organ. Tiny little organ. The whole organ's about 5 millimeters. Tiny little organ caused the majority of cancer deaths in American women in 1952. Okay? And by 1992, it had basically disappeared. It's number 14 today. What happened? It's not because we found it early. You find cervical cancer early or late, it's a horrible disease. It's still a horrible disease. Often incurable. We're not finding it early today. We used to find it late. It's not about early detection. And it's not about better treatment. We do treat it better today than we used to, but not a whole lot better. The cancer disappeared. So how do you make a cancer disappear? All right. So here's the kind of the 30,000-foot view. 95% of cancers in adults come from something the thickness of a piece of paper. 95%. Breast, bladder, thyroid, lung, liver, oral, esophageal, laryngeal, cervical, colon, pancreas. They're all bladder. They all come from something the thickness of a piece of paper. They come from the lining of those organs, the epithelium. The epithelium is 500 microns thick. So breast cancer, you think of breast cancer as an ugly lump in the middle of the breast, right? It ends up that way. It didn't start that way. The breast is a milk machine. It's filled with ducts. The ducts are lined with an epithelium, right? A lining, a thin lining. Bladder cancer comes from the lining of the bladder. Well, the pancreas is filled with ducts. Those ducts have a lining that's 0.5 millimeter thick, 500 microns thick, thickness of a piece of paper. It came from there. Esophageal cancer comes from the lining of the esophagus. Colon cancer comes from the lining of the colon. All of these things come from something the thickness of a piece of paper. Why is that? Okay? So this is that, you've seen pictures like this in your dermatologist's office. This is the 500 microns. This is the 0.5 millimeter right here. The lining has got cells in it. It doesn't have any blood. It doesn't have any lymphatic flow. Right? There's no lymphatic flow or blood flow in this lining. So think of the lining of your mouth or the lining of your throat, the lining of your esophagus. There's no blood or lymphatic flow. Why not? Because if there was, every time you ate a carrot or shook somebody's hand, you'd bleed. So the lining can't be thick. Okay? It can't be thick. Why can't it be thick? Because since there's no blood or lymphatic flow, if the epithelium went up to here, these cells up here would die because they get nourishment from down here below this thing called the basement membrane, and the esophagus is called the lamina propria. So so you can't have a thick epithelium. You have to have a thin one. Now, because you can't have a thick epithelium, and because this is your interface to the inner and outer world, it's always being damaged. So the body's strategy is to constantly slough it off and replace it. You don't have a cell in your mouth outside of your teeth that was there a week ago. That's why I could take these glasses, if you drank from them, take a cotton swab and get your DNA. That's how we catch crooks today. We're constantly sloughing off our epithelium. Urinate into a jar, tons of cells. Your bladder lining is constantly being sloughed off. So is the prostate. So all of your linings are being sloughed off and replaced. It's constant. It's constant. Right now, during this half hour, you're probably shedding 10 million cells and replacing them. 10 million cells right now in this half hour and replacing them. It's a constant process. The cervix is recycled, is regenerated every 6 weeks. So if you get any typical pap smear, don't go back to the doctor. Wait 6 weeks. You need new cells. The esophagus is probably a month. Some studies say 3 weeks. There are areas of the small intestine that get regenerated every 3 days. You're constantly sloughing off and replacing this epithelium because these are like the security guards, right? This is the interface. So this is the bladder, the urine's up here. If this is the cervix out there, if this is the esophagus, your sushi's going down this way, right? This is the interface to the inner and outer world, so it's constantly being replaced. In order to replace your epithelium, you have to do something called mitosis, right? You have to make new cells. So this layer down here, this layer of the basal cells, these are stem cells. Your entire lining of your body are cells that are making copies of themselves to replace that epithelium. How do you change the lining of your mouth or your esophagus in a week or a month? You have to make new cells. How does the body make new cells? Well, if this is a cell, it's going to make a copy of itself, and then you got two daughter cells, right? It's called mitosis. When the cell makes a copy of itself, it's got to copy billions of base pairs of DNA. It's like a document. If I want to make a copy of this book, I have to copy all the pages in it. So there's billions of base pairs of DNA every time one of these cells makes a copy of itself. So what's going on here? You have a new cell here this is the mouth, let's say. It takes a week. This cell is hatched on Monday. It's over here, it's on Wednesday. Friday, it's here, and then it disconnects. And a new one takes its place. It's out in the saliva, you spit it out, and the one that was here on Wednesday is now here on Friday. But for all that to happen, you have to make new cells down here on Monday, right? You're constantly making new cells. It means you're constantly doing mitosis, which means you're constantly copying your DNA. Billions of base pairs of DNA have to be copied. When you do that, usually it works. Sometimes there's a mistake. An adenine could be replaced with a thymine or a guanine. You could replace one of the nucleotides. Now, the DNA has repair mechanisms that's fascinating, that actually detect that and fix it. And that usually works, but sometimes it doesn't. And what happens then is the two daughter cells are going to have a mistake. They're going to have that thymine instead of an adenine. And somewhere in there, billions of base pairs on those chromosomes, they're going to have a mistake. One mistake's okay. But think about it. When those cells have daughters, what's going to happen? Their daughters are going to inherit that mistake. So within, let's say, 5 months, in this little patch of your cervix or your esophagus or your bladder, you're going to have millions of cells with no mistakes and a clone of maybe 10,000 cells with one mistake, right? And a few years later, that clone will be bigger. That's still okay. One mistake's not going to hurt you. But what if one of those cells with one mistake that you got in 2016, in 2026, right? One of those cells, when it divided, it made a second mistake, right? Its daughters are going to have how many mistakes? 2. The one it got in 2016 and the new one. So now you're going to have millions of cells with no mistakes, 100,000 cells with one mistake, and maybe 30,000 cells with 2 mistakes. 2 mistakes is also okay. But what if one of those cells with 2 mistakes, 2 years down the road, gets a 3rd mistake? Now you're going to have even a smaller clone of cells with 3 mistakes, and so on. A cancer cell requires 8 mistakes. That's why we're not all dropping dead of cancer. It takes a long time. So this explains a few very important facts. Why are 95% of cancers in adults carcinomas? Kids get different cancers. Their bones are growing, they get blood cancers, they get lymphomas, different things. Adults get carcinomas. Why are 95% of cancers in adults carcinomas? Because the only place where you're doing mitosis is replacing that lining, which you're constantly doing till the day you die. And because you're doing so much mitosis, because you're replacing so many cells, there's an opportunity to collect mistakes. It also explains why carcinomas don't apply to younger people. You don't see 30-year-old women getting breast cancer, or 25-year-old women getting ovarian cancer, or 28-year-old guys getting prostate cancer. It doesn't happen. Why not? They haven't lived long enough to have a cell in those organs that accumulated 8 mistakes. Why don't you see 30-year-old people getting colon cancer? They haven't lived long enough. You have to live long enough to have at least one cell, and all you need is one. All you need is one cell. There's a great book on cancer by Greenberg called One Renegade Cell. All you need is one cell that went over that line and got its 8th mistake. It's out of control. Multiplies, metastasizes, bad news. Now, here's the key thing for us. So this, once a cell's got 3, you need all 8 mistakes to be cancer. If you have a cell with 3 mistakes, you don't have a little bit of cancer. You don't have cancer at all. It's like a series circuit, the switches, right? You need all 8 switches have to be flicked for the lights on a Christmas tree to go on. You need all the switches to go. If you have 1 or 2 or 3 switches, the lights don't go on. Now, this happens in a week, right? For this cell, now, to go from there to there, this takes years to accumulate 8 mistakes. Once a cell's got somewhere between 2 and 4 mistakes, something interesting happens. It looks odd under the microscope. It's still harmless. You need all 8 mistakes for the lights to go on. But once it's at 2 to 4 mistakes, it doesn't look right. The nucleus is too big. It's not round anymore. It's granular. And that was first recognized by a Greek gynecologist by the name of George Papanikolaou, who was looking at cervical cancer in hamsters. I don't want to even think about that. But that's where he got started. And then he got involved with people. The man saved tens of millions of lives. Tens of millions of lives. He realized that if you gently remove the mucus, when a woman's got cells with 3 genetic errors, that cell, here's here on Monday, here on Wednesday, here on Friday, it's out here in the cervical mucus. So when you do a pap smear, you pick up that cervical mucus, you put it on a slide. She has no symptoms, she doesn't have cancer, but she's got misshapen cells. So that's a Greek word. Dysplasia means bad form. He's Greek, he can name it whatever he wants. So that's where the word dysplasia comes from. It came from George Papanikolaou. And this was, we recognized these abnormal cells, they trace it over time. Women with these abnormal cells eventually got cancer, and that's why cervical cancer disappeared. We preempt it. We see a cell with 3 mistakes. If you destroy the cells with 3 mistakes, guess what? You never allow them collect another 5. That's the whole trick here. So this works. It took cervical cancer from number 1 to number 14. Where else are we doing this? Colon. By the way, what's the first symptom of cervical cancer? Interperiod bleeding, heavy interperiod bleeding. Remember I said there's no blood in the epithelium, right? That's why it's so thin. So to get heavy interperiod bleeding, what has to happen? The 8th mistake is it drills a hole here in the basement membrane and the blood oozes out. That's why blood freaks us out when it comes from a place where we're not supposed to bleed. You cough up blood, urinate blood, defecate blood, that's usually a hemorrhoid, but it bothers us. Why does it bother us? Because we subconsciously know, I'm not supposed to have blood there. That could be a bad thing, right? Interperiod bleeding is usually a fibroid, but sometimes it's cancer. And that's what got to go to the doctor. But that's not dysplasia. You see, until you get to the 8th mistake, there is no bleeding. So if you wait until patients bleed, that's like waiting until someone can't swallow for esophageal cancer. It's too late. So what's another cancer we can now prevent by detecting dysplasia? Colon cancer. The first symptom of cervical cancer used to be interperiod bleeding. Now we don't wait for that. We detect it as a precancer and we destroy those cells. We never let the patient get cancer. The first symptom of colon cancer in the 1970s was what? Hey Martha, there's blood in the toilet, right? Blood in the stool. That's too late. That's not dysplasia. Same story. We don't allow that to happen anymore. Unless the patient's got Crohn's or colitis, that should never happen. Person gets periodic colonoscopy, sporadic colon cancer, which is detected as a polyp. What are those? The reason we know, by the way, how many genetic errors it takes to become a cancer cell is really from studies of polyps in the colon. Because when you cut them out, you see all the different stages of the progression of the molecular changes from dysplasia to cancer. So that's how we learned all this in the 1980s. But basically, colon cancer is now a preventable disease. Cervical cancer is a preventable disease. Person gets a pap smear every couple of years, they won't get colon cancer. Skin cancer, more or less. You have a mole that looks odd, not round, not one color, and so on. It's not, show it to the dermatologist. Colon cancer, gone. Esophageal cancer. One of the reasons why there's so much excitement about Watts is because of RFA. If it weren't for RFA, what's the therapy for high-grade dysplasia? Esophagectomy, right? Nobody wants that. Mortality rate of 50%, I'm sorry, morbidity rate of 50%, mortality rate of 3 or 4%, not a good operation. It's almost like people didn't want to find high-grade. By the way, low-grade dysplasia is somewhere around 3 to 4 mutations. High-grade dysplasia is 6 to 7, 5 to 7, that range. And cancer is 8. So somebody has high-grade dysplasia, they cut their esophagus out. That's what they used to do. And nobody wanted to do that. It's almost like they didn't want to find the dysplasia. What's the point? It's like, because there's so much enthusiasm for WASP, because now people realize esophageal cancer is a preventable disease. You see, in the cervix in the 1960s, ablation, to ablate something this big, you have to think about it, right? Ablation in the cervix was easy because it's such a tiny organ. They worked out ways to ablate the tissue in the 1960s. LEAP, electrocauterization, cryo, that was all worked out in the cervix in the 1960s. And it was easy, and the woman maintained her reproductive capacity. So it was a huge success. If it weren't for Watts, RFA wouldn't work. There's a great study by Corley that shows that surveillance is useless. That the number of patients that survive 5 years with and without surveillance is the same. Because the random biopsy is so bad, right? If it weren't for RFA, Watts would have much more limited appeal. So I just want you to kind of get that story. But here's why. Why does RFA work? Why is it just dumb to take somebody's esophagus out for dysplasia? The esophagus is like, here, let me show you, I got a picture. The esophagus is all that. This is an exaggeration. This is not to scale. That's the epithelium. If you wanted, dysplasia in Barrett's is limited to this. That's all you want to test. That's also all you want to treat, right? To take somebody's esophagus out, which is a huge operation, is kind of dumb, isn't it? If all you want to get rid of is this. Why does RFA work? Radio frequency ablation works because you're only treating something the thickness of a piece of paper. And you only need to test something the thickness of a piece of paper. Drilling holes deep into the esophagus, right? If I want to know if there's oil in Pennsylvania, I don't want to drill holes that are 5 miles deep and 50 feet wide, but that's what you're doing with the forceps. It makes no sense. You want to test more of the epithelium. That's what Watts does. Addressing the sampling error of drilling these holes. Why are they drilling holes? Because that's all they knew how to do in the 19th century. In the 19th century, no one knew about how to prevent cancer by detecting dysplasia. None of that was worked out. In the 19th century, you had someone who looked sick and you did a big biopsy and you found out they were sick. You detected cancer, you didn't prevent cancer. We're in the prevention business. When they introduced colonoscopy in this country, they made a huge mistake. They said, and Katie Couric got up there and she did one on television, I'm not sure how that worked out, but she basically, her husband died of colon cancer, that early colon cancer detection saves lives. Nobody wanted to test. And they blamed the PrEP, they blamed everything under the sun. You know why they didn't want the test? Nobody wants a cancer test. They'd rather go to the mall, right? Because nobody wants to think of the possibility of the bad news. When you tell patients, I've got a way to prevent cancer, we probably sell billions of dollars worth of vitamins in this country on the 1 in a 1,000 chance that one of them might prevent cancer. That's why everyone's drinking bottled water. This probably does make sense. But the point is that prevention sells. And people get that, and they want that. And so this is what revolutionized colon cancer.
Yeah, I got tested. It's no big deal.
Come on, Bob. How's a test going to prevent colon cancer?
I'll show you.
This is Robert. He knows you can actually prevent colon cancer by getting tested.
Do they take a look at your colon? And if they find a polyp, they get it out before it turns into cancer.
No, you didn't.
Oh, yes, I did.
If you're 50 or older, talk to your doctor about getting tested for colon cancer. Or for free information, contact us today. This is the American Cancer Society.
So that had a revolutionary effect. So you had this crush of people that needed colonoscopy, and until the 1980s, nobody had a GI, If you ask someone in 1970, who's your GI, no matter how old they were, they'd look at you a funny look. It's like asking someone today, who's your hematologist? God forbid I should have one. What are you talking about, right? GI was, like gynecology in the 1950s. Women went to the OB to have a baby. The pap smear changed gynecology. Everyone has to have a pap smear and a pelvic exam. It turned it into a primary care intervention. Colonoscopy turned GI to a primary care intervention. That's why, and so this is why, if we've now made esophageal cancer as preventable as colon cancer, that's going to resonate.